In this Chemscape presentation, we will look at toxic process gases found in workplaces during industrial processes. These gases are usually contained in a pressurized environment that requires continuous monitoring. When containment is broken accidentally or intentionally, there is a potential for a release to occur, and serious illness or death can result from exposure to workers in the public. In this presentation, we will review what a toxic process gas is, their hazards, how to work safely with them, and how to be prepared in the event of a release. Toxic process gases are often used for oil and gas, industrial processes, cold storage facilities, and in the treatment of materials like disinfection. They are found in arenas, swimming pools, water treatment plants, refrigeration facilities, and manufacturing. In this table, we have listed common toxic process gases like ammonia, chlorine, hydrogen sulfide, and carbon monoxide with their associated GHS hazard pictograms. Let's now look at their health effects. Treat all airborne vapors, fumes, and mists with the same precaution. Toxic process gases present immediate physical threats upon contact. They can cause rapid skin corrosion and deep chemical burns by reacting with body moisture, while the eyes are at risk for permanent damage or blindness from even brief exposure. Furthermore, these gases can act as sensitizers, where an initial exposure triggers a permanent immune response, leading to severe allergic reactions or asthma-like respiratory distress during any future contact. Beyond immediate injury, chronic exposure can lead to long-term health complications. These substances may be mutagenic, causing permanent DNA damage, or carcinogenic, significantly increasing the risk of developing various cancers over time. Furthermore, they can act as reproductive toxins, impacting fertility or causing developmental harm to a fetus. Finally, repeated exposure often leads to specific organ toxicity, where the gas targets and progressively damages vital systems like the lungs, liver, or kidneys, often long after the initial contact. These gases can also be an asphyxiant hazard. A sufficient level of oxygen in the air we breathe is essential. A release of an asphyxiant gas or vapor can disrupt the level of oxygen in the air and cause unconsciousness or death by suffocation. There are two categories: simple asphyxiants and chemical asphyxiants. Both types interfere with the supply of oxygen in the air and have the same health consequences. In an ideal atmosphere, oxygen is 19.5 to 23.5%. You inhale oxygen and it is exchanged in your lungs through the alveoli. Here the bloodstream binds the oxygen molecule to hemoglobin, your red blood cells, and carries it to your tissues and organs around your body. When the ideal atmospheric level of oxygen drops and becomes deficient, it can have serious and immediate effects on a person. This includes unconsciousness after only 1 or 2 breaths. The exposed person has no warning. As the table shows, symptoms worsen rapidly at concentrations lower than 16%, from rapid breathing and heart rate to nausea, collapse, coma, and death. In an atmosphere with less than 10% oxygen, a person can fall into a coma. It is important to have a safety data sheet for all your products, and this includes gases which may be contained. Refer to Section 2 of the safety data sheet for the hazards of the product you are working with. Before working with any product, you should be able to answer fundamental questions on the products you are working with, including: what are the hazards? How do I protect myself from harm? What do I need to do in case of an emergency? Where can I find more information? Safety begins with the design and engineering of facilities. Under normal operations, the risk from the hazards of these toxic gases is low as they are contained. To maintain safe environments, facilities have workplace procedures, continuous monitoring of work areas, and preventative maintenance and inspections to ensure toxic gases are contained. The safe work procedures for a facility are based on comprehensive risk assessments conducted by qualified health and safety professionals. These procedures provide standardized instructions for the safe handling of toxic process gases and are essential for maintaining a secure work environment. Review the protocols at your worksite. Common procedures may include gas handling instructions, system startups and shutdowns, monitoring and maintenance for equipment, and leak detection and safety protocols for lone work. Understanding and implementing these procedures is a fundamental requirement for operational safety. Another control includes barriers and access restrictions set up around work sites. These may include containment to block any accidental releases, ventilation with fresh air, entry and exit points that are kept unobstructed and well marked, restricting areas to authorized personnel. If you work alone, follow the written procedures on entering enclosures of toxic process gases with poor ventilation. Checks done at regular intervals and recorded can include visual checks, radio contact, or a telephone call-in procedure. An end of shift or task check-in must occur. There must be a search and rescue alert and awareness of what to do if a worker cannot be contacted or is injured. Ventilation systems are installed to exhaust toxic process gases directly to the outdoors. Regular maintenance is done to ensure proper operation and good working condition. Emergency ventilation capability should be available in the event of an accidental release. Continuous monitoring systems are installed to detect emissions and accidental releases. They are connected to alarms that warn workers and trigger controls during emergencies. Systems need to be tested monthly and calibrated annually. PPE may be required based on task and risk. A respirator may be required if toxic process gases may enter the breathing zone. In restricted access enclosures, workers may need to wear or carry an emergency respirator. Workers should understand escape and evacuation procedures, how to notify EMS and community, how to bring emergency under control, plan for re-entry. Ensure your emergency response equipment is ready. Equipment may include detection equipment and alarms, radios, eye washes and showers, first aid kits, and AED. Test equipment regularly and keep records of inspection. In the event of an accidental release, workers need to be able to shut down manually the gas supply from a remote location or by the alarm system to stop the flow of gas. Be aware of the emergency shutdown at your worksite. Pipes, compressors, and fittings should be labeled in your workplace. Identify what gas is contained inside. Color coding identifies critical components and the function of every control device. Piping systems must be corrosion resistant, rated for system pressure, structurally protected against impact and shock, leak and pressure tested, equipped with isolation, venting, and bleed valves to safely purge lines before maintenance. Good practices are effective only when personnel, including contractors, are trained in equipment operation, ventilation and monitoring systems, oxygen deficiency hazards, hazard communication and SOPs, confined space safety, precautions for toxic gas environments, and emergency response procedures, including shutdowns. This concludes our presentation on toxic process gases. Use the knowledge you have gained from this presentation to protect yourself from chemical exposure in the workplace and in your personal life. This video is intended as an educational tool only. Please consult regulations in your area for specific requirements.